Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. We are in the chapter of limits from differential calculus and in today's video we will discuss about exponential limits. Particularly first we will prove these two limits and then we will see how to use these limits while solving the problem. So some of the questions are written on the board. Along with this we will solve few more questions on it. Okay, first let us see how to prove these two limits and then we will see their applications. So let us start. So very important form in exponential limits. So we have the question. We have to prove that limit x approaches 0, a power x minus 1 divided by x is equal to log a base e. How do we prove it? Obviously using expansions. Okay, let me take LHS. Limit x approaches 0, a power x minus 1 divided by x. And what is the expansion of a power x? So we have learned it in the previous videos. Do check limits using expansions in the playlist of limits. Okay, coming back to the expansion of log x, it is 1 plus x into log a base e. Okay, next plus x square into log a base e whole square divided by 2 factorial plus x cube into log a base e whole cube by 3 factorial and so on. I'm not writing all the terms because obviously the other terms will become 0. Okay, so then we also have minus 1 here. I just wrote the expansion of a power x. Okay, then minus 1 whole divided by x. So plus 1 and minus 1 gets cancelled. Now x is a common denominator. We can give it for each term. Okay, so limit x approaches 0. So the first term divided by x. So x and x will get cancelled. You will get log a base e. And second term divided by x square by x will be x. So x into log a base e whole square divided by 2 factorial. If you want to write the third term, x cube divided by x will become x square into log a base e whole cube by 3 factorial and so on. They are not needed. Why they are not needed means obviously now when I substitute x as 0, this term will be 0 into something which is 0. Next term is also 0 square into something which will be 0 and all the remaining terms will be 0 in this expansion. So all the remaining terms are 0. We are left out with only log a base e, which is our answer. So which is equal to log a base e. So therefore limit x approaches 0, a power x minus 1 divided by x is equal to log a base e, where a is particularly positive real number and a should not be equal to yes, a can be equal to 1. Is it a can be equal to 1? We generally don't take the base as 1. Okay, so fine. We'll see a basic example. Limit x approaches 0, 5 power x minus 1 divided by x. Okay, so which is equal to what? It will be log 5 to the base e according to this formula. Okay, now a basic application of it. Now some important note point on this particular limit. What is it? Let us see. So just now we proved that when x approaches 0, this particular function approaches log a base e. Correct or not? Now when x is approaching some real number, let me call it as b. Let us say that x is approaching some real number b. Any real number. Okay, now if f of x is approaching 0, when x approaches a real number b, if f of x is approaching 0, then what can we say? We can say that limit x approaches b, a power f of x minus 1 by f of x is also equal to log a base e. Because when x is approaching b, f of x is approaching 0. Correct or not? F of x is approaching 0 and a power is f of x. The denominator is also f of x. In that case, this function, this is same like this function. In case if you want more clarity, you can replace f of x with y. So what happens here? Limit y approaches 0, a power y minus 1 divided by y. So this and this both are same only na? Instead of x we have y, so it is equal to log a base e. So that's why I said when x is approaching b, if f of x is approaching 0, then limit x approaches b, this one is equal to log a base e. A simple example, let us see. Limit x approaches pi by 2, a power, or let me say 5 power or 6 power cos x minus 1 divided by cos x. So what is the answer, dear students? When x is approaching pi by 2, cos pi by 2 is 0, correct or not? When x is approaching pi by 2, cos x is approaching 0. So this is in this form, where f of x is cos x. So therefore, what is the answer? The answer is log 6 to the base e. We can write it directly like this. Okay, remember this kind of forms will be used while solving the problems. Okay, next, second proof. Instead of a, what if we have e, dear students? So limit x approaches 0, e power x minus 1 by x. What about this? So limit x approaches 0, e power x minus 1 by x. So what is it? Instead of a, we have taken e. So it is log e to the base e, and log e base e is equal to 1. So therefore, dear students, limit x approaches 0, e power x minus 1 by x is equal to 1. Okay, and moreover, when x is approaching a or any other number, any real number a, if f of x is approaching 0, then obviously e power f of x minus 1 divided by f of x is also equal to 1 only. When x is approaching some real number a, if f of x is approaching 0, then this will be equal to 1. If you need a simple example, let us say limit x approaches 0, e power x sin x minus 1 divided by x sin x. See, when x is approaching 0, if you take this as f of x, when x is approaching 0, 0 into sin 0 is also 0, correct or not? So x into sin x is also approaching 0. So e power f of x minus 1 by f of x is equal to 1. We can write it directly. Okay, so that is how we will use its applications while solving the problems. Now let us start solving the problem, and remember one thing, we can also prove it using L'Hospital's rule, correct or not? Let me give an overview of how to prove it using L'Hospital's rule. For example, I want to prove that limit x approaches 0, a power x minus 1 by x as a log a base e. So what I'll do, I'll take LHS. Obviously, if I substitute x as 0, a power 0 minus 1 is 0 divided by 0. It is in 0 by 0 form, correct or not? Obviously, we can use L'Hospital's rule. So according to L'Hospital's rule, numerator derivative divided by denominator derivative. So a power x derivative is a power x into log a base e minus 1 derivative is 0 whole divided by x derivative is 1. Now if you substitute x as 0, a power 0 is 1 into log a base e. So which is log a base e. So we can also prove it using L'Hospital's rule. Okay, now similarly you can also prove this using L'Hospital's rule. You can try this. Okay, so now let us start solving the problems. Here is our question. Limit x approaches 0, 5 power 3x minus 2 power 2x divided by x. So let us see how to solve it using a power x minus 1 by x form. So let me write it as, what I am going to do in numerator is, I will subtract 1 and I will add 1. So 5 power 3x minus 1 minus 2 power 2x plus 1. So I just subtracted 1 and I added 1 and with common denominator. So dear students, limit x approaches 0. This is 5 power 3x. We can also write it as 5 cube whole power x, and 5 cube is 125 power x, correct or not? Minus 1, and in these two I will take minus common. 2 power 2x means 2 square whole power x. 2 square is 4 whole power x, and I have taken minus common in these two now, so plus becomes minus 1, and this is common denominator. Obviously I can separate it. So now dear students, we already know that limit x approaches 0, a power x minus 1 by x is equal to what? Log a base e. So in that case, what is the answer for this? Here a is 125. So therefore, when I apply the limit for this, I'll get log 125 base e minus. Similarly, if I apply limit here a is 4 now. So what I'll get? Log 4 base e, and using log m minus log n, it is log of m by n, correct or not? Log of 125 by 4 base e, that is the final answer. Remember this, what logarithmic formula we have used? Log m minus log n is equal to log of m by n. This is equal to log of m by n if the base is same. Here we have base e na, base e. So We have used this form to get the final answer. Okay, we will go with next question. And before going on, what is the answer? It is equal to log of 125 by 4 base e. Okay, that is the answer. We'll go with next question. Here is our next question. Limit x approaches 0, 21 power x minus 3 power x minus 7 power x plus 1 by x sin x. Obviously, if I substitute x as 0, the numerator will become 0 and the denominator will become 0. It is in the form of 0 by 0. And I am going to use the exponential limits. So before using it, you should understand that I can factorize the numerator. So how can I factorize the numerator? In these two, I can take 3 power x common. If I take 3 power x common, 3 power x into 7 power x is 21 power x. Correct or not? Minus, I have taken 3 power x common, so there will be 1 here. And in these two terms, I can take minus 1 common. Minus 1 or plus 1, but I will choose minus 1. Minus 1 if I take common, I will take 7 power x minus 1. Okay, na? And denominator is as it is, x into sin x. And next thing, if you observe, dear students, here and here we have 7 power x common, limit x approaches 0, 7 power x minus 1 into 3 power x minus 1. So I have factorized the numerator successfully. Next, in the previous step, can I do this? I'll divide sin x with x and also I'll multiply with x. Why? Because limit x approaches 0, sin x by x is how much? 1. For that reason. Limit x approaches 0, sin x by x is 1. In trigonometric limits, we have learned this. And we are left out with x into x. So what shall I do is, x into x, one x here and another x here. I hope you understood this. I did it directly. You can also mention, since limit x approaches 0, sin x by x is 1. So sin x by x, you will get 1. I just wrote it here. And dear students, limit x approaches 0, what is this? Because limit x approaches 0, a power x minus 1 by x is log a base e. So using this formula, this will be log 7 base e into this will be log 3 base e. And some students will write the answer as log 21 base e. That is not correct. There is no formula for log m into log n. We do not have it. So we will leave the answer like this. So this is the answer for this question. The answer is log 7 base e into log 3 base e. That is the answer. Okay. We will go with next question. Fourth question. Once again, if I substitute x as 0, then I will get 0 by 0 form. So how are we going to solve it? Very simple. By looking at the denominator, you should have got an idea. So we will multiply this with its rationalizing factor, okay, na? Or its conjugate. What is it? Limit x approaches 0, 3 power x minus 1 divided by root of 1 plus x minus 1 will be multiplied with its rationalizing factor, root of 1 plus x plus 1. So I multiplied it in the denominator. I should also multiply it in the numerator. And using a minus b into a plus b. So what do we get, dear students? A square minus b square. And you can give limit for this function separately. Limit x approaches 0, root of 1 plus x plus 1. Right? And in denominator, square and root gets cancelled. 1 plus x minus 1 will come. Plus 1 and minus 1 also gets cancelled. Okay, now plus 1 and minus 1 also gets cancelled. And we are left out with what? Limit x approaches 0, 3 power x minus 1 divided by only x into. Here I can substitute x value as 0, right? Root of 1 plus 0 will be 1. 1 plus 1 will be 2. And dear students, now we already know that limit x approaches 0, a power x minus 1 by x equal to log a base e. I can use that formula here. So this becomes log 3 base e with what coefficient? 2. And in properties of logarithms, we learned that this 2 can become the power of 3 here. So it becomes log 3 square base e, which is equal to log 9 base e. This is the final answer. So therefore the answer is what? Log 9 base e. I hope it's easy for you. We will go with next question. Question number 5. If I directly substitute x as 1, it is in 0 by 0 form. So obviously let us see how to solve this question. Important model, please observe how I am doing it. Limit x approaches 1. Let me take e common in these two. Why should I take e common in these two? So that it will be converted as e power something minus 1 for that reason. Okay now. So when I took e common in these two terms, it becomes e power x divided by e minus 1 whole divided by sine pi x. Okay, let it be. That this conversion will be done in the next step. Next, limit x approaches 1, e power x into, this will become what? E power x minus 1. Yes, because e power x divided by e power 1 will be e power x minus 1 as it is. Look at this. This is like e power f of x minus 1, where this f of x is approaching 0. Why is it approaching 0? Because x is approaching 1, x minus 1 is approaching 0. So it is in the form of e power f of x minus 1. If it is in the form of e power f of x minus 1, in the denominator, if there is f of x, I can use the formula. I will say what is that formula. Okay, now. So therefore, dear students, let me multiply the denominator with x minus 1 and also the numerator with x minus 1. And already who is there? Sin pi x is there. I will do something here. Let me write sin pi x as sin pi minus pi x. Because sin pi minus theta is sin theta only. So for that reason, sin pi x is sin of pi minus pi x. Both are same. Now dear students, we know that limit x approaches a, f of x approaches 0, e power f of x minus 1 by f of x is equal to 1. When x approaches a, if f of x is approaching 0, then this limit is 1. So for that reason, the value of this will be equal to 1. Okay, now. So therefore, in the next step, so x approaches 1, I can substitute x as 1. Okay, so e power 1 into, this entire limit's value is 1 into, so we have to apply limit only for this. Limit x approaches 0, x minus 1 divided by, observe I can take pi common, correct or not? So sine of pi into x minus 1. X is not approaching 0, I am sorry, x is approaching 1. We are very close to our answer, dear students. Let me take minus common in these two. So minus e into limit x approaches 1, 1 minus x divided by sine of pi into 1 minus x. So now again, dear students, do you remember? What do we remember? Do you remember? Limit x approaches 0, sine kx by x is equal to k, or limit x approaches a, if f of x is approaching 0, then sine k into f of x by f of x is also equal to k. So if I apply that, what will I get here? Minus e into, it is the reciprocal of it. This is the reciprocal of this form. Okay, so I will get what? 1 divided by pi. That means what? You can take this to the denominator. So you will get pi here. So 1 divided by pi. And the final answer is minus e divided by pi. Minus e divided by pi. Are you confused here? I hope you are not confused. This is like f of x divided by sine pi into f of x. Okay, now same like this. If it is in this form, I'll get k. If it is in this form, the reciprocal of it, I'll get 1 divided by k. So 1 by pi, you'll get the answer as minus e by pi. So the answer for this question is minus e divided by pi. Okay, we'll go with next question. Our next question, this is also obviously in 0 by 0 form if you substitute x as 0. See once again, I'll try to convert the given question in the form of e power f of x minus 1 by f of x. Limit f of x approaches 0, e power f of x minus 1 by f of x is 1. So if I convert the question into this form, I can take 1 there. For that reason, what I'll do is limit x approaches 0. I'll take e power x common here and here. If I take e power x common, you'll get e power x cos x divided by e power x. Okay, now minus 1 whole divided by x cube plus x into sin x. Next, in the next step, limit x approaches 0, e power x into a power m by a power n. A power m minus n. Okay, now minus 1 as it is. Denominator is, okay, fine. I'll write the denominator later. Now observe here, when x approaches 0, if you take this as f of x, 0 into cos 0 minus 0 will be 0 only. So it is in the form of e power f of x minus 1. So like this. If it is in the form of e power f of x minus 1, I want f of x in the denominator. So let me divide it with this f of x, which means x cos x minus x. I divided with this now, let me also multiply with it, x cos x minus x. And already who is in the denominator? Divided by x cube plus x into sin x. Right? So next, this will become 1, this value. This one is in the form of e power f of x minus 1 by f of x na. So its value will be 1, and e power 0, if I substitute x as 0, what I'll get? E power 0, and this limit's value is 1, and we have to find the limit of this function. Limit x approaches 0, what is it? X, can I take x common? X into cos x minus 1. And in denominator, let me take x square common. You will understand why. A small correction in the question, this is actually x square, okay? X square, and then, yes, this is x square, okay? Now let us continue. I have taken x common, and in the denominator I will take x cube common. If I take x cube common, this becomes 1 plus. I took x cube common now, so this term becomes sin x divided by x. Now x and square, x cube will get cancelled to give you x square. Okay, x and x cube will get cancelled, will give you x square. So it is equal to e power 0 is 1. 1 into 1 is 1. Let it be. Limit x approaches 0. If I take minus common, I'll get 1 minus cos x. And let me give this x square for this person, divided by 1 plus sin x divided by x. Now observe one thing, dear students. You know the value of this limit. We have been using this so many times. If you observe the video of trigonometric limits, you will understand. The value of this limit is 1 by 2. So the numerator will be minus 1 by 2 divided by 1 plus limit x approaches 0, sin x by x is 1. So what is the final answer, dear students? Minus 1 by 2 divided by 2, and it is minus 1 by 4. The final answer is minus 1 by 4. The answer for this question is minus 1 by 4. Okay, let us go to next question. Pretty easy question, but important model. If the limit of this function is 3, we are supposed to find the values of p comma q. Okay, now easy question only. First, see how I am approaching it. Dear students, when x is approaching 0, the denominator is approaching 0. Okay, now, and the answer is a finite non-zero number. Okay, the answer is a finite value. If your answer is finite value, and if denominator is approaching 0, then the numerator also must approach 0. Keep this in mind. What is the meaning of it? So which means that when I substitute x as 0, what I'll get? P into e power 0 minus q na. This value is the numerator's value. It should approach 0. That is the first clue you have to understand. Once again I am repeating. When the denominator is approaching 0, numerator also must approach 0, because the answer is finite answer. If the numerator is not approaching 0, if the numerator is approaching any other number, then what happens? Imagine the numerator is approaching 2. Then 2 by 0 will become infinity. Correct or not? We are not getting infinity as answer. We are getting a finite number. For that reason, when denominator is approaching 0, the numerator also should approach 0. So, okay, now, anyhow, I have substituted x value as 0. Na? I got p into e power 0 minus q, and which is nothing but p minus q. P minus q is 0. P is equal to q. This is the first clue that we have got. So, remember, p is equal to q. Next, after this, what I will do is, see here. Limit x approaches 0, p into e power x. Okay, now somehow I should convert it as p into e power x minus 1. For that reason, what I'll do is I'll subtract p and I'll add p. And already we have minus q. Okay, next, the common denominator is x. The common denominator is x. Okay, now, so it is equal to 3. We can take p common, correct or not? Limit x approaches 0. What is it? If I take p common, it becomes e power x minus 1 divided by x plus p minus q by x equal to 3. Let me have this common denominator instead of separating. Okay, instead of separating, let me have this as common denominator. Okay, now, so the common denominator. So as we have observed that p minus q is 0, you substitute 0 here. And the question becomes what? If p comes outside, limit x approaches 0, e power x minus 1 divided by x equal to 3. And the value of this limit is 1. So p into 1 will be equal to 3. What is it? P into 1 will be equal to 3. Therefore, p is equal to 3. And if p is equal to 3, because of this, q is also equal to 3. So that implies p is equal to q, both are equal to 3. So that is the answer for this question. You can verify it. If p and q both are 3, you can take 3 common and you will get the answer. Just like that you can verify it. Okay, now both the values of p and q are 3. Okay, fine. I'll give one question, you can try it yourself. Here is a question, you can try this question and let me know what is the answer in the comment sections. By chance, if you are not getting the answer, you can also comment the same thing in the comment sections and I'll upload this solution in the form of shorts in our channel. So you can check it. Okay, that's it in today's video, dear students. I hope you have understood the concept of exponential limits and how to use those limits while solving the problems. So do share it with your friends and like the video. So we'll see you all in the next video. This is Sandeep Kumar.